this is going to be from discussion 2, exercise 5. This is going to be the other part of showing that the sum from k equals 1 to n of k squared is actually equal to n times n plus 1 times 2n plus 1 over 6. Alright, so proof I'm going to go through is actually, there's a problem in the book in section 6.1, problem 31 on page 291. It will take you through these steps. So first we're going to take this sum. So what we're going to do first, it's not going to look like this k squared. What we're actually going to do first is going to be the sum from k equals 1 to n of 1 plus k cubed minus k cubed. Alright. Well, let's write out the terms of this. This is actually going to be, well, let's see, the first term is going to be 2 cubed minus 1 cubed. Right. So that's 2 cubed. And then we're going to add to that, well, each of these is going to go up by 1, so it'll just be 3 cubed minus 2 cubed plus 4 cubed minus 3 cubed plus 5 cubed minus 6 cubed, and so on, all the way up to, we will get, what would be n plus 1 cubed minus n cubed. Okay. So if you want to look at this, you notice, well, there's a 2 cubed here, minus 2 cubed here. All these parentheses are kind of unnecessary. They're just showing which term I'm in. So 2 cubed minus 2 cubed, well, that'll cancel out. 3 cubed minus 3 cubed, that'll cancel out. 4 cubed, I skipped one, didn't I? Nope. This isn't 6, this is a 4. My bad. 4 cubed minus 4 cubed, that'll cancel out. And the 5 cubed will cancel out with the 5 cubed over here, and we'll keep going. So in each term, the first part of the term is going to cancel out with the second part of the next term. Right? And so they're there, and so we're going to keep going. And the first term here is going to cancel with the second part of the term here, and we're going to be left with, what are we left with? We get n plus 1 cubed minus 1. Okay. So that is equal to this sum here. Then let's take a look at the sum another way. So this sum, I could also expand this cube. So this will be the sum from k equals 1 to n of, I'll have 1 plus 3k plus 3k squared plus k cubed, and that goes minus k cubed. And this just comes, there's a formula for cubing things, or you can take it individually, you FOIL, and then you distribute again, and you'll find you'll end up with this. I recommend writing that out if you don't immediately believe it. And then, well, that'll cancel out. And then the sum, well, we can split it up into smaller sums. So sum from k equals 1 to n of 1 plus the sum from k equals 1 to n of 3k plus the sum from k equals 1 to n of 3k squared. So this is equal to this sum. But this sum is also equal to this guy. So this is equal to this is equal to this. That means this is equal to this. Okay, so I'm just going to put that right there. n plus 1 cubed minus 1 is equal to this guy over here. Well, I know what most of these are, actually. So n plus 1 cubed minus 1 is actually equal to, well, this is just n. This, I can pull out the 3, and I'll end up with 3, and then I get n times n plus 1 over 2. And this guy over here, well, I pull out the 3, and, well, now I've got 3 times the sum, k equals 1 to n of k squared. But that's what I'm looking for. Okay, so now it all makes sense. Now I can solve for that. So, let's see. Subtract the n, subtract the 3 times n plus 1 over 2 over to the other side. And let's also expand this. So we'll have n cubed plus 3n squared plus 3n plus 1 minus n minus 3n times n plus 1 over 2 is equal to 3 times the sum, k equals 1 to n of k squared. Down from the previous line. Alright, so this is expanded here. I brought this stuff over here, and I'm left with that. And, well, these ones will cancel out. And what else do I have? Okay. So, let's get this all to be over 2. Oh, okay, yeah. Let's put this all over 2. So this is really 2 times n cubed, and then plus 6 times n squared. And this will be 2, so this is actually plus 4n. So 3n minus n gives me 2n, but I'm putting it over 2. So this is actually going to be 2n becomes 4n. And then this guy's already over 2, so it'll be minus, and then we distribute, so it'll be 3n squared minus 3n. Well, now I want k squared, so I'm going to divide out my 3, which means I've got a 3 in the denominator over here. And now, if we look carefully enough at this, my sum of k squared is actually going to be something over 6. Combine some terms here, I'll get 2n cubed plus 4, nope, sorry, plus 3 n squared plus n. And if you factor this out, you'll see this actually factors out into n times n plus 1 times 2n plus 1. So we get exactly what we were looking for. N times n plus 1 times 2n plus 1 over 6 is equal to k squared, or the sum of k equals 1 to n of k squared. And there it is.